Welcome. In this video, I want to talk about artificial intelligence. Specifically, I want to talk about the following. What is the minimum input data given? What's the minimum input data given a unit like pixels to be able to render or recreate a perfect copy of a photo or picture. I'm not an expert on this, but I just thought about this topic. I'm aware of things like AI recognition systems. I don't. I'm not aware of the details, but I'm aware of that they do exist. I'm also aware of optimization, AI optimization, image recognition, nodes or node systems, node AI systems, as well as other systems, other AI systems, pattern recognition, among other things. But I thought about this without any expertise or knowledge about this topic in not even in basic knowledge. But just knowing what I know about AI, the little bit I know about AI, which I plan to increase in the future and make more videos about it. But I thought about this. I think the answer to this question, what is the minimum input data? Okay, let me explain to you what I mean by that. Let's say I have a photo or a picture. Let's say it has a tree on it. Then you have a river. Then you have a couple of rocks and volcanoes and okay, so that's a, let's say this is the original copy of what I want to recreate. Of course, thinking about AI, if I give you the whole picture, then the accuracy of my picture should be 100%. I just copy unit by unit, whatever unit you're using, if it is pixels or binary code or binary raw data, then it should be 100%. But what if I start taking out bits of it? So my question to this is, what's the minimum I can take out to be able to render the same original picture Of course, if I take out everything, the answer should be 0. If I have everything, then the answer should be 100, because you already have it. You just have to copy it. But what if I leave it like this with all these little modifications? Would I be able to render or recreate the original picture? I thought about this uh, in basic thoughts, and I thought that that's variable. I think it varies. The reason it varies is because two things I'm gonna expose to you. In math, we know we have patterns. If I know the original patterns of a picture, then I would say we can get close to 100% or 100%. Then it will be close or 100%. Let me give you one example. Let's say I have a fractal. Let's say a basic fractal. Let's do something like this. Let's say the fractal goes like this. Fractal is something that start building up. But let me give you a basic thing. Let's say I have a square, and I know that square gets smaller and smaller at regular pattern. And if I know that that's a fractal, or like if I know that that's a that's a pattern, that is, if I already know beforehand that that's a pattern, then it gets close or 100%. If it's something like this, it's 100%, because you already know how small it's gonna get in each generation. But then when it comes to like real life, like not real life, like other objects or life, uh, human beings and other stuff. For example, let's say you have nature. Nature has patterns too. As we know, the Fibonacci numbers, the Fibonacci fifths numbers come up in nature, so we can definitely be able to be close or 100% predict an image. But then we also have, okay, so that one, this variation, you have to talk about these patterns. The other stuff is when you have functions. We know in math that a function, we know it can, we don't, if I tell you the range, we don't know if it's gonna go up. We know that it crosses at a certain points, but we don't know whether in between it's gonna go here or it's gonna go here. That's something I learned in mathematics. So in those cases that we don't know, we don't have a regular pattern, then we definitely can't say that we're gonna get 100%. We can attempt it, but we cannot get 100. We can definitely attempt it. And remember, we talk when we attempt it, we're talking about randomness and random and guessing. Then we can get close or 100%, or sometimes not even close. Now go back to the original problem. If I so knowing this information that I think it varies depending on the type of input, the type of photo you have, then if we know we have patterns, then we can definitely approach 100% or close. But if, for example, this picture, how do I know this thing doesn't go here like that? I wouldn't be able to tell you without knowing anything about that tree. But if I know something about that tree, then I would be able to give you a better a better rendering, a better recreation of the picture. So so when I say what's the minimum input, I was talking about, in other words, how much I can take out or how much I should have in order to be able to render the original picture. And the answer to that, it varies. If it is a pattern, I might be give you what the minimum input is, might be less than something like this that has irregular patterns. But the only case where, like I said, the trivial case is when you have the entire picture or when you have no picture. Then you can definitely, those are the only two cases where I think you will definitely be able to recreate it perfectly. And the other case is if you know the pattern beforehand. Yes, then definitely you can. If you know information about the picture, then you can definitely get better results. But my curiosity is, I believe there has to be something like an equilibrium point where you can determine if something, there has to be, for every object, there has to be a minimum, or every object or anything in nature, any human being or anything in nature or the universe, there has to be a minimum number of input data needed in be able to recognize it and generate a prediction or recreate it. How accurate? Then we have to talk about these things. But at least AI can definitely be useful in these particular cases, because when we talk about X-rays, if we have a knowledge of how things go about, how things look like, or sizes, X-rays, we can definitely make a prediction about things that the system can see. And as far as I know, sometimes you can get really good predictions with X-rays, but you have to train the system. And these are some of the things that I think play in this type of scenarios, like X-rays, pictures, photos, face recognition. But yes, I believe there is a fix. There is a minimum, something like an equilibrium point, where you will be able to determine what you will be. I think the equilibrium points where you will be the minimum. Let me put it this way. So let's say that E stands for equilibrium. Then and then X is number of input data or datum. Then E of X, I believe, well, unless it's infinitesimal, then we'll have to adjust it. But then I think EX is fixed. In the case of factors that can go into infinity, then although they are infinite, we can still, I think that once the system knows that that's what it's doing, then we know that something that X has infinity, like infinitesimal things, we can say that it's fixed. For things like fractals, patterns, the only things that the only things that we can definitely not say that are fixed are when we start talking about x exact. Then if you don't have any of these uh, environments, then we have to say that it varies, because we don't know how a function goes in the middle, if it goes up or down or whatever. But if we know a pattern for those functions, then it's a different story, then it sticks. But then if we don't know it, then it varies. Thank you very much. That's all I wanted to show you on this video.